In this video, we will discuss the basics of probability, which is a value that describes the likelihood of something to occur. Similar to many of the other topics we have discussed this year so far, such as mean, median, mode, standard deviation, and correlation, probability can be represented by a single number, and that number can be estimated or computed. The range of numbers goes from 0 to 1. The closer the value is to 1, the more likely something is to occur. If an event had a probability of 0, it would be impossible to happen. And if it had a probability of 1, it would be certain to occur. For values in between, we usually represent probabilities using fractions or decimals, and sometimes percentages. Before we get into how to calculate probabilities, we want to become familiar with some of the notation we will see and some of the definitions we will use. The letter P is what we use to represent a probability. So in the examples and formulas we will see going forward, we will see a capital P to represent probability, and then we will see the name of a specific event, which in a formula might be represented by an A, a B, or a C. So if I were to write a capital P followed by parentheses with the letter A in between, I would be referring to the probability of event A occurring. A is just a generic letter we use in formulas. When we do specific examples, we usually write the event names in. You can see in the example here, I'm representing the probability I will live for 200 years, which is essentially 0. Three definitions we would like to know include definitions of a simple event, an event, and a sample space. The word event is used to describe the outcome of an action or an experiment. A simple event is a specific outcome of an action or an experiment, while an event can be a collection of one or more simple events. The sample space is a list or a set of every single possible outcome of some action or experiment. To give you some examples, if my action was to roll a six-sided die, a simple event would be rolling a 3. That would be one specific outcome of our action. Rolling a 3 could also be referred to as an event, but an event can be more generic in nature. An event can be a collection of simple events. So an example of something that is an event, but not a simple event, would be rolling an even number. Rolling an even number is an outcome of rolling a six-sided die, but it's made up of the simple events of rolling a 2, a 4, or a 6. The sample space for this example would be a collection of all the possible simple events. So for rolling a six-sided die, the sample space would be rolling a 1, 2, 3, 4, 5, or 6. When computing the probability of an event, there are two general techniques used. The first technique is really an estimation that uses the knowledge of relative frequency of a past sample. If you wanted to compute the probability of some event occurring, you would need to use information about how many times the event occurred in the past divided by how many opportunities there were for it to occur. To give an example of this, suppose I wanted to compute the probability that I would arrive to class on time if I left for school 30 minutes before class. Well, there's no way to compute the actual probability of this event on this specific trial. But what I can do is estimate it off past experiences. So if I have a sample of 20 times that I left for school 30 minutes before class, and I successfully made it on time 18 out of those 20 times, well then I would estimate that the probability I'm going to make it to class on time this time would be 18 out of 20, or about 90%. The second way to compute a probability of a single event is used when you have the knowledge of every possible outcome of your experiment or action, and all of those outcomes have an equally likely chance of happening. If this is the case, you can calculate the probability by taking a ratio of how many outcomes are favorable to your event divided by the total number of possible outcomes. To give an example of this, we'll go back to our action of rolling a six-sided die. For that action, I know all the possible outcomes. They're 1, 2, 3, 4, 5, or 6 listed in the sample space. So to compute the probability that I would roll a 3, since there is only one favorable outcome out of the 6, the probability would be 1/6. If I wanted to compute the probability I would roll an even number, I would need to gather all the events, all the simple events, favorable to that event, which would be 2, 4, and 6. There's 3 of them, so the probability I would roll an even number would be 3 out of 6. One of the biggest mistakes people make in computing probabilities is always assuming that every outcome is equally likely to occur. In the example we have here, all 6 outcomes are equally likely to occur. But on our previous example, when we found the probability of making it to class on time, if we left 30 minutes prior to the start of class, it would be incorrect to say, well, there are only 2 outcomes. Either we are on time or we are late, so it must be 50-50. We would be incorrect in assuming those outcomes are equally as likely to occur.